it now. So, so let's just continue with 1.2 formulas and applications. Can you upload this PowerPoint to Blackboard? Yes, I will do it later. Once I usually upload the PowerPoint in Blackboard after we finish this section. If you want to review, then please go to the video. Please watch the video and download it if you want in Blackboard, and that will include everything. Okay, but I will upload the slides of each section after we complete the section. Right after we complete it. All right. Okay, I think my connection is not good today. Why? Let's just continue with applications. We talked about formulas and we did a few examples of applications and continue with that topic a little bit. A lot of times you have some problem in reality and you don't know where to start, how to start the problem. Okay, so let's talk about a simple interest problem. So in the bank, yes, Dejani, I can see you. Do you have a question? Okay, let's talk about simple interest. If you have an account in the bank, and then you get some interest. Can you hear him? Yes, can you hear me? Can everybody hear me? I know I got a little problem with video. I want to make sure you can hear me at least. Okay. Yes, I can't or can. Jamaya. Yes, okay. Yes, can. All right, great. You know. All right. So then you want to know, you may be curious how to calculate the interest you get, and there are different types of interest. In the very basic case, it's called a simple interest. So you have an annual interest rate, like 5%, for example, then you just multiply the rate by the principal, the amount you deposited, to get the interest for 1 year. Okay, so in simple interest, the interest earned is the principal times the interest rate. If you read the sentence, underlined on this page, it says in simple interest, the interest earned is the principal times interest rate. That's the interest you earned in 1 year. So in this problem, an accountant invests part of a 6,000 bonus in a 5% simple interest account and invests the remainder of the money at 8.5% simple interest. So when you have a job, you work in a company, for example, then they usually have some bonus at the end of the year that for you to put different financial products. So in this case, there are two options. You can either put the 5% simple interest account or 8.5% simple interest rate account. And then together at the end of the year, the investment earns $370. So we need to find the amount to invest at each rate. Originally, what amount was put in each account? That's the question. We know the total amount, the principal is $6,000, and we know there are two accounts. One is 5% rate, and the other is 8.5 rate. And at the end, he got $370 as the interest. So we want to know how much did he put in each account originally at the beginning of the year. All right. To solve a word problem is always the rule to assign the variable to start. Just assign the variable to the question asked. I think I'd said that before in this problem. We need to find the amount invested at each rate. So let's just let X be the amount of money invested in the 5% a simple interest account. Okay, you can also, you know, put let X be the amount in 8.5%. It doesn't matter. So let's just use X be the number principal in the 5% account. Then 6,000 is total. If you subtract X from 6,000, then that will be the principal amount in the 8.5% simple interest account. Okay. Then you can compute the interest from each account by the formula we just had. So the interest from 5% simple interest account will be X, which is the principal in this account, times 5%. So 5% is just 0.05. So we got 0.05X for the interest from this account. And make sure you know 5% converted to decimal is just 0.05. And then you do the similar way to find the interest from the 8.5 simple interest account. The principal in the 8.5 rate account is $6,000 minus X. As we already know, that's the amount deducted, the 5% from $6,000. And then the interest rate is 8.5%. So you just multiply 6,000 minus X times 0.085. And if you distribute the 0.085, you're going to get the 510 minus 0.085X. 6,000 times 0.085 is 510 if you do it. And then you can add these two interests because we know the total is 370. So 370 should be 0.05X, which is the interest from the 5% rate account, and the plus 510 minus 0.085X. That's the interest from the 8.5% account. So if you combine like terms, move 510 to the left and change the sign, so it becomes negative. And then combine the terms of 0.05X and the negative 0.085X. You're going to get negative 140 on the left and the negative 0.035X on the right. Now, divided by negative 0.035, you're going to get 4,004X. So that's the amount you deposited in the 5% rate account originally. Then obviously the remainder of 2,000, 6,000 minus 4,000, that's 2,000. That's the amount in the 8.5% simple interest account. Any questions on this question, on this problem? Okay, so that's the simple interest problem. What's the name of this type of problem? That's called a simple interest problem. So I can look at practical problems. Okay, yeah. Yes, all right. Any other questions? Okay, I guess the next type of problem is called, uniform motion or something. Okay. So let me make sure we're in this right page. Okay. So the next example, we talk about the uniform motion. Okay. So it says a ship travels from a harbor to an island at a speed of 15 knots. So that's 15 nautical miles. It's a little bit more than 1 mile. Nautical mile is a little more than 1 mile. So 15 knots is 15 nautical miles per hour. Okay, so that's the speed of the ship from the harbor to the island. He travels from the island to the harbor. So this is the round trip. On the back trip, the speed of the ship is reduced to 10 knots because of the wind. It's reduced. So we know if duration for a round trip is 75 hours. In total, it takes 75 hours for a round trip. How far is it from the harbor to the island? What's the distance between the harbor and the island? Okay. So the formula here we use is the duration for one-way trip. Okay. If we talk about just one way, is distance divided by speed. Okay. That's the formula. So then again, we start assigning a variable to the question we asked. So it's asking how far is it from the harbor to the island. Let's just assume it's just x. So let x be the distance from the harbor to the island. We can use that to find time for each trip. So duration of the forward trip from the harbor to the island is over 15,000. This distance of 15 is for the forward trip to the island. Similarly, duration of the back trip from the island to the harbor, okay, that over 10 because the back trip is 10 speed. So if you add these two times, you should get 7.5 hours total duration round trip. Okay, we need to solve this equation. You see some fractions here. So there are different ways to do it. For example, you can find this common number until that 30, isn't it? And then you convert each fraction by using the least common denominator. So you're going to multiply 2 to the first fraction on the top and at the bottom at the same time. So you got 2x over 30 for the first term, and then you multiply 3 on the top and at the bottom in the second term. So you got 3x over 30. So then you get the same denominator that you can add. You have to have the same denominator to add fractions. Then what you do is just add the numerator and keep the denominator. So we got the 2x plus 3x, which is 5x over 30, equal to 7.5. And then you just easily solve this equation by flipping 5 over 3, 5 over 30 on both sides. So multiplying 30 over 5, you get about 7.5, you get 45 if we do that. 45 nautical miles. So that's the distance between the harbor to the island. Any questions for this problem? I guess I will not do any more problems today because it's already 3:50. But make sure we got everything. You got the message today. We got a lot of stuff to fix. You need to make sure you're ready for the quiz. What type of problem was the last one? This is called uniform motion. Uniform motion. Any other questions? Let me just stop the